in our final presentation on behalf of Quad Squad. So for our pipeline, we do text pre-processing, which feeds into our question generation and answer generation. Questions are then ranked. For the question pipeline, we begin with pre-processing using coreference resolution to create coreference chains, sentence parsing, specifically constituency parsing, and sentence separation, where we take sentences with conjunctions and break them down into smaller sections. Question generation includes binary question generation, which we then leverage for our WH question generation. We then do question post-processing, where we remove extra content. For rank, we do length of question and type of question as our main heuristics. For binary questions, we handle two different cases, when a helper verb exists and when it does not exist. In the case where it does exist, we essentially swap the helper verb and the proper noun in the sentence. When there is no helper verb, we check the tense and whether or not there are plurals, and then use that to choose the word to start the question. Did, do, or does. In the case of WH questions, we begin with our who question, where we essentially rely on the NER tag. We remove the entity from the sentence and then add who at the start of the sentence. For what, we do essentially the same process, except we look for when there is not an NER tag. In the case of whom, we check for the word label in or to and look for the word by. If the word has a NER tag following it, we then take the word by and the NER tag words following that and then create a binary question and add by whom at the front of the generated binary question. We follow a similar approach for when, except we instead rely on the NER tag for date or time. We do the same process where we remove words, create a binary question, add a word. We do essentially the same thing with where, except we look for location or GPE tags. In the case of which questions, we look for determiners and check whether or not there's an adjective following the determiner. We then remove the determiner and the adjective if it exists, and keep the noun and append which in front of the noun. For how many, we check for the cardinal tag and again whether or not there's an adjective, and follow essentially the same approach. In the case of how, we look for an adverb and then ensure that it is not in this list of adverbs that are on the screen. We then remove the adverb and add how at the start of the generated binary question, where the binary question was generated without the adverb. In the case of why, we look for a preposition and the word because, remove the part of the tree following the word because, create a binary question, and add why at the beginning. We then rank on the basis of the length of the question, where we prefer words in the 4 to 20 range, or questions in the 4 to 20 word range. If we run out of questions in that range, we then prefer shorter questions, and then lastly longer questions. We then rank based on the question type, where we prefer questions that do not require NER tags because we had difficulties with our NER tags. For an answer pipeline, we detect the type of question, use cosine similarity across the Wikipedia file to find a candidate sentence that matches the question, use the text of the return sentence for generating our answer, and then generate answers specifically based on the question type. For detecting question type, we essentially look through the question string to see whether a WH word exists or not. If it does not exist, we assume it's binary. When answering binary questions, we essentially check whether or not negation exists. The algorithm can be seen on the screen, but we essentially check whether there's an even or odd amount of negations in the sentence and question or not. In this case, there's 2, so the answer is yes. If there's an odd number, it's no. For answering who questions, we create a constituency parse tree, look at synonyms and antonyms once again, and then look for proper nouns or noun phrases. If there are commas, we split on the commas into smaller fragments and run the cosine similarity once again. Here you can see a worked example where we returned the NNP tag from the candidate sentence. For answering other WH questions, such as what, we follow a very similar approach. Same for whom questions, where we check the NNP and NNPS tags. In the case of when and where, we instead rely on NER tags instead of our constituency tree. So for when, we look at date or time tagged in our candidate sentence, and in where questions, we look for location or GPE tags. In the case where we were unable to correctly find the subcomponent of the sentence to return, we instead return the full cosine similarity sentence. Here you can see some short results. So these are question and answer pairs that our system successfully generated. Some of them are a little bit less successful, as you can see here. In conclusion, our system performed reasonably well on binary questions and WH question, which NER tags were not used, but in cases where NER tags were required, it failed. It also required high quality co-reference resolution.